Right, hello, welcome to homework 3.21. Let's go ahead and get started looking at um, these problems. So today we looked at determining from a table whether it is reflecting a linear function or an exponential function. So this first one shows the height of a ball after a different number of bounces. You might remember when we did this earlier that that was exponential, but we're going to go ahead and verify. So let's first look at the difference between each bounce. So 83 going down to 61 means that I'm going down a difference of 22. So here's minus 22. And then 61 minus 46 gives me 15. And then 46 minus 35 is 11. So notice these are all pretty different amounts. So that doesn't look like it's going to be a linear function because it's not decreasing by the same amount each time. But then let's go ahead and look at what the rate would, or what the factor would be. So if we do 61 divided by 83, we get 0.734. If I do 46 divided by 61, I get 0.75, also pretty close. 35 divided by 46, I get 0.76. And then 26 divided by 35, I get 0.74. So these are all 0.7 something, so they're all within the hundredth, like a hundredth of each other. And so we would say this would be more accurately modeled by an exponential function. So we're going to say no here because the differences are 22, 15, 11, and then this last one was 35 minus 6, so 9. And so those differences are all different. Yes, more accurately, because we're looking at 0.73 to, that's a TO, draw, to 0.76 as a factor, which means they're all relatively close to each other. So if we create a model for the ball, our initial value wouldn't have been 83. That's after one bounce. So we would need to go backwards. So let's first choose our factor here. And let's say that our factor is, we'll choose kind of in between 0.73 and 0.76. So let's do we'll just 0.74. Tend to be a little on, maybe a little on the higher side. So let's do 0.75. All right, so we'll say 0.75, so 75% of the bounce roughly is going to be our factor. That's what's left after each one. And it is decreasing, so it should be less than 1. We can check our work, make sure that works, and to the nth bounce. But then I need to find out what was the 0th term, what was the height. So 83 divided by 0.75 gives me 110.6. We can say 110.6. And then that gives us our model of height equals. Used to estimate the height the ball was dropped from. Oh, okay, well, I've already done that, 110.6 there. Use your model to estimate how many bounces it takes from the rebound height before the rebound height is less than 10 centimeters. So here you can go into your y equals, 110.6 times 0.75 to the power of x, and hit second table. And then we can go down and look and see where was that less than 10 centimeters. So we get to less than 10 centimeters around the 9th bounce. So it is after the 8th bounce. About 9 bounces. Okay. It says, Mai used a computer simulation to roll number cubes and count how many rolls it took before all of the cubes came up sixes. Here's a table showing her results. Okay, so she's been rolling these number cubes and counting all the rolls it takes to get to the number of sixes. It says, would a linear or exponential function be appropriate for modeling the relationship with D and R? Explain how you know. Looking at this automatically, right? You can see that there's a huge jump in between all of these. And so I'm immediately going to say probably not linear, right? Here we're increasing by 26, and then we go from 31 to 143. That's quite a large leap. And so we're obviously not increasing by the same amount there. Sorry about that sudden noise. So Len, let's go ahead and check and see what we're looking at in terms of factor. So if we do 31 divided by 5, it's going to be 6 point something, right? 6.2 here. We do 143 divided by 31. We get 4.6. And then if I do 788 divided by 143, I get 5.51. So do we think, looking at those different factors, right, we have pretty different differences, and we also have pretty different factors. What does that mean about whether this is exponential or linear? I would say if I had to pick one, then it would be more likely exponential because it's between 5, around 4.6 is leaning more towards 5, between 5 and 6, um, being multiplied by roughly a factor of 5 or 6. So that would probably be a little bit better. It's not exactly perfect. I'd like to see these values, our ones values, be a little bit closer to each other to say that it could truly be an exponential function, but exponential would be better for this. So exponential is better because the factors are closer than the increases between each number of cubes, right? Because this is such a vast difference between each of these, the exponential function would be a little bit better there. Okay, a ramp is 2 meters long. Priya wants to investigate how the distance a basketball rolls is related to the location on the ramp where it was released. Recommend a way for Priya to gather data to help understand this relationship. So this is more open-ended in terms of what would you do to help Priya determine how far, right, the distance, how far the basketball rolls related to where it is released. So if this is our ramp, right, and then she rolls the basketball. We're trying to decide how far will it go after she rolls it. If I roll it from here, will it go further than if I roll it from here? Than if I roll it from here. So you want to think about what is a way that she would gather data to understand this relationship. What would she measure and what would she do? This one I'm not going to give you an answer because I want you to really think about that one and be able to explain what you would do if you were doing this experiment. All right, number 7, there are graphs of these 3 functions. Which function decays the most quickly? Which one decays the least quickly? So remember, decaying the most quickly means that it's steeper and it is very quickly descending, right? And so we would say that z decays most quickly. And then I want you to tell me which one decays least quickly. Because if I've given you that, you should definitely be able to tell me which one decays the least quickly or the slowest. All right, number 8, the bungee jump in India is 83 miles high, or sorry, 83 meters high. Miles would be quite a bit. The jumper free falls for 5 seconds to about 30 meters above the river. Draw a graph of the bungee jump. Identify and describe 3 pieces of important information you can learn from the graph of the bungee jump. So you're going to draw a little sketch of our bungee jumper at 83 miles. 83, I keep saying miles, 83 meters high. All right, so he's free falling for about 5 seconds to 30 meters above the river. So his first fall, he's free falling for about 5 seconds. So 1, 2, 3, 4, 5, until he gets to 30 meters above the river. So at 30 meters above the river, what happens with a bungee jumper? Well, over the next period of time, the bungee pulls him back up to a certain height, and then he comes back down, right? And so you're going to see kind of like a basketball bouncing up and down, right? The bungee jumper is coming up and then back down over time until eventually they stop. So It says identify and describe 3 pieces of important information you can learn from the graph of the bungee jump. So one would be the starting height, which we know is 83 meters high. Then we know the minimum or the lowest height, right? Because he's going to fall to 30 meters above the river. That's when it stops and then he comes back up. So they've made it so that he does not hit the river. Um, and then I want you to think of one more piece of information that has to do with what happens towards the end and thinking about time. So maybe how long does it take the bungee jumper to come to a stop? All right, these problems are to help you practice for the unit test, so take a careful look at them and ask any questions that you might have here. So a savings account earns a 4.8% interest each year. So we're earning interest, which means we're increasing, compounded quarterly 4 times a year. That means we need to divide that 4.8% interest over 4 times, and then we're going to be multiplying it to the power of 4. If a person invests $200 and makes no withdrawals or deposits, what is the balance in account after 5 years? So 4 times a year plus then to the power of those 5 years. So let's take a look at this. We have a starting amount of $200. Then we are going to be earning 1 plus that 4.8% interest divided by those 4 times that we are compounding the interest to the power of 4, because again, we're doing that 4 times, and then all to the power of 5 because it is happening over a period of 5 years. You can also rewrite this as, let's see, 4. Oh, actually here, you know what I did too? Let me adjust this. So that 4.8 is in percent, so it needs to be written as a decimal as 0.48. So 0.48, or excuse me, 0.048 divided by 4 gives us 0.012. So you can also rewrite this as 200 times 1.012 to the power of 20, because 4 times 5 is 20. And a power raised to the power, we multiply. All right, so again, just reiterating that 4.8% is written as a decimal as 0.048, and then we need to divide it up 4 times because it's happening 4 times in 1 year. Because it's happening 4 times and we're compounding 4 times, we're putting it to the power of 4. And then we're talking about 5 years, so we are then raising it again to the power of 5. So we ultimately have to the power of 20, because over those 5 years, we will compound 20 times. All right, the function c of x equals 96 times 1.13 to the power of x models the cost in dollars. C of 1 ounce of medicine used in a pharmaceutical. X represents the number of years since 2000. Does the cost of the chemical increase or decrease over time, and by what percentage per year does it do so? So because we see that this is 1.13, we know that this is an increasing function or a growth function. And that 13 tells us it's growing by 13% because it will grow to 113% of its original value. How much does an ounce of the chemical cost in 2018? So we're going to go ahead and calculate 96 times 1.13 to the power of, year since 2000 is 18. All right, so again, this part right here, you're going to calculate. I'm going to be looking for your homework that you have filled in this little pink box and that you have actually calculated that part on your own. You can use a calculator. I don't expect you to be able to do 1.13 to the power of 18 in your head. All right, number 11 says here's a graph that represents this equation here. Change my highlighter color. The pink is a bit much. Okay, so this equation right here. The coordinates A of A are 1 comma C. So let's go ahead and label that 1 comma C. And the coordinates of B are 5 comma D. It says, what is the value of D over C and how do you know? So D over C, right, if we're looking at a period of from 1 to the 5th number here, right, we're increasing here by 1, 2, 3, 4. So we want to know how much we're getting to each time. Now here, I'm multiplying by 2.5 each time to get to the next value, right? And so if that's the case, I'm increasing x by 4 here. So it would be 2.5 to the power of 4, which is 39.0625. Now, if you wanted to prove this, you could show this by doing 6.5432 times 2.5 to the power of 5, that's our later value, right, divided by 6.5432 times 2.5 to the power of 1, right? When we do this, this is 1 because it's the number divided by itself. And then here we have same base with exponents, so we can subtract the exponents. So it would be 2.5 to the power of 4 would be what remains there. Okay, and so without having to do all this calculation, we recognize that the increase of x is by 4, and so therefore d divided by c would be 2.5 to the 4th power, or 39.067. Number 12. When a child is born, her grandfather decides to put $200 in an account that earns interest. He plans to make no other deposits or withdrawals for 12 years. So starting amount is $200. When the child turns 12, the money in the account will be a birthday gift. The grandfather is choosing between two options: an account that grows by 7.5% or an account that grows by $30 each year. All right, so let's make our equations. Growing by 7.5% we know means that this is going to be exponential. So 1.075 to the power of 12. Why 12? Because we said we're doing this for 12 years. And then in this case, we have a starting amount of 200, but then it's increasing by $30 each year. Again, that repeated addition here, I'm adding $30 each time. And so we represent that as 30x. And so this is 200 times 1.075 to the power of 12 gives us $476.36, or option 2, which would be 200 plus 30 times 12, which is 560. So in this case, for a 12th birthday gift, which one would you want to choose? Because again, we're only doing this for 12 years. So you explain to me here which one you would choose and why. All right, your code word for today is TEAL, T-E-A-L. Write that at the top of your paper and you can earn extra credit. Make sure to study, go back and review, make sure you know the difference between exponential and linear functions. Make sure you know how to calculate the factor, okay, so how much something is increasing by, and that you can also use it to predict things based on time. The last piece I would make sure you study and review is compounding interest, particularly if it's quarterly, biannually, or monthly, and knowing how to recognize and represent that in equation form. All right, again, if you have any questions, reach out to me. Happy homeworking, and I will see you tomorrow.